When you have a bunch of raw data, you can place all that raw data under a bell curve. That's a really bad bell curve. Let me see if I can draw that a little bit better. So, that's much better. You're going on the bell curve. You're going to have the average score be right in the middle of that curve. So they call that the mean, and the mean is shown by mu. Okay. If I'm looking at the z-score for that, the z-score for that is going to be a z-score of 0 because it's right in the very middle. And if you look at the equation for z-score is equal to the data point itself minus the average all over the standard deviation. And the standard deviation basically tells you kind of where the spread of the data would be. Okay? And there's a formula that you can use in order to find the deviation from the raw data itself. But this is what you kind of need to know. If you know how far apart each one of the points are in the data, then you can find when the z-score is 1. And so I'm going to put 1 here. So let's say that your standard deviation, let's say this is like 50, right? So that's your average. And your standard deviation is, I'll call it 15. Then if I go 1 standard deviation away from the average, then, so I'm going to call that 1 standard deviation away. So this actual number would be 65. Okay? And then if I take a standard deviation away from my average, so this would be your negative standard deviation, then that would be 15, or 50 minus 15, which would be 35. Okay? Those gives you a z-score of 1 and a z-score of -1. And all of that data in between those 2 points, when you're actually doing this, 68% of your data is in between those 2 points. When you go 2 standard deviations out, so now I'm going to take 35 and subtract 15 from it. So this point would be 20. And then I'm going to add 15 to it, and that point would be 80. And that's 2 standard deviations out, so you would call that 2 standard deviations. So that would be -2, and then the z-score here would be +2. And all of the data in between those 2 points, I think, is 97% of the data. It's like another 13.5%. So 26 plus 68, or 27 plus 68 is 95%. That sounds about right. So 95% of all the data will be between those 2 points, between those 2 scores. And then if you go 1 more standard deviation out, then you have almost 99% of all the data. This is how this is actually going to help you in your future life. Because I know a lot of people ask, what the hell do I need to know this for? When you go to college, right, some teachers' grading scales aren't like 90 to 100 is an A, okay? What they do is they take the average score of all of the kids, and then they find the spread of the data, and then if you fall within 1 standard deviation of the data, then you get an A. If you're within 2 standard deviations of the data, you get a B. So in layman's terms, like let's say the average score on something is, let's say it's, because this is actually real life, let's say it's 45%. That was the average score on a test, right? And the standard deviation of the data is 15, right? So this would be your C. Your C would be a 45%. If you got a grade like a 60, right, because that's one standard deviation away, that would be your B. If you got a 75 or above, that would be your A. If you got one standard deviation below that, which is a 30% on a test, that would be your D. And then anything lower than a 30 would be an F. And that's how some folks in college actually grade along a bell curve. They say it's a bell curve grade. And you do that because in some classes, not all the kids pick up everything they need to pick up. So they basically normalize everything. So they take it from the average instead of taking it from the best score. Because if you're taking the average score and then you're doing a standard deviation to the left or to the right of that, then it's actually more fair for the students that are actually in the class. Because if you look at it, if you have something like this, then over 60% of the kids that take your class should have actually passed, right? Yeah. So that's what an actual z-score or standard deviation is. So let's do a couple of questions that you actually have on this thing. So flip the thing over so we can actually see how to use it. Okay, so in the first question, it says that the mean of the data set is 92, or 192, and that the standard deviation is 17. And they want to know what would be the value of the z-score for each one of those points. So each one of those points is actually your x value. So for the first x value, that would be 50. Okay? So now we're just going to use this equation to figure out where on this bell curve that score actually lies. Okay? So I'm going to say that the z-score is equal to 50 minus 192 all over 17. And so let me pull out my calculator. So I'm going to do 50 minus 192, and then I'm going to divide that by 17. Oh, that's really, really bad, because that's not even going to actually be on a table for you to get a percentage on it. So your z-score in that case would be -8, because I think it only goes up to like 4 or 3.5 on that table. So pull out the table. Yeah, see, it only goes up to 3.5. So you wouldn't even be able to get that z-score on the table because it's so low. So 0.35. That would be the z-score. So you do the next one for me.
Okay, so be 100 minus 192, and all of that divided by 17. So -92 divided by 17.
Okay, let's stick that in there. -92 divided by, and that's not even on the table either. -5.41. So that would be way over here somewhere. Okay, let's do the next one. Honestly, I'm not going to say anything because I'm being recorded right now. Let's do the next one.
So 150 minus 192 all divided by 17. So that would be 42 divided by 17. Nee.
Okay, so we do 42 divided by, I'll just make it negative. Oh, now we can actually get a probability. Okay, so that was negative 2.47. So if we look on our z-score chart, those numbers that are on the chart are the actual probabilities for that z-score.
So what are the ones?
Okay, so to read this, you're going to go to negative 2.4, and then you're going to go over to 0.07, and where the two connect, that would be the actual percentage grade that you would get on that. So it's 0.6%. Right? If I move it over twice, it would be 0.68%. So that would be the actual percentage for it, 0.68%. The actual score on the table was this number. So the numbers on the actual z-score table tell you the probability of actually getting that particular value.
Okay, so up here would be the second number?
Yeah, the very last number is up there. And then on the side are these two numbers. That's how you actually read it off the table. Okay, let's do the next one.
Okay. So 200 minus 192, which would be 8 divided by 17.
Positive 8 divided by 17. So it's going to be somewhere around 1/2, right? So I'm not trying to do that in my head. 8 divided by 17. That gives us our z-score. So our z-score is 0.47. Okay. And if we read the table, we're going to go to the 0 number. It's at the very top. And then go over to 7. And then tell me what that probability is. It's got to be around 50%, right?
0.6808.
Okay, so this is 0.6808. So then the percentage would be 68.08%. And the last one.
250 minus 192, everything divided by 17, which would be 58 divided by 17.
And calculator, 58 divided by 17. That gives us a z-score of 3.41. And then tell me the probability that you get from the chart. $90-something?
0.9997.
3 nines or
3 nines.
3 nines, okay. So that would be 99.97%. That means that 99.9% of the data is below that line. So that means that only 0.03% of that data is above that line. Okay? Okay, what's the second thing asking us to do?
This one is to write the equation.
So you're writing in terms of the raw data point itself?
Yes, to get x and to get the z-score.
Okay. So let me erase this. And then I'm going to hit